so I can share.
Okay, welcome everyone. My name is Aurelio Muraca. I'm the technology program coordinator here at the Danbury Library. And once again, I welcome you to series 2, episode 4 in our Earth in Crisis series. And tonight's topic is, what is a civilization and how do we save ours? With biology professor at Western Connecticut State University, Dr. Mitch Wagener. And Dr. Mitch, thank you again for joining us this evening. You have the con, sir.
Okay, let's see. You'll have to tell me, make sure that I've got everything going here.
I will.
Okay, do you see Anchor Watt in your screen?
Hold on a second. Yes, I do. There you go.
All right. Okay. Well, civilization is a big term, and a lot of people interpret it in a certain way. So I want to broaden out the notion of civilization a little bit. It is without a doubt, the big ancient civilizations that we studied in school with ruined buildings that we can visit. This is Angkor Wat in Cambodia. I've not been there. It's on my to-do list of things to see, but I just haven't been there. And civilizations more than just Beethoven's Ninth Symphony and the works of Shakespeare and all those sorts of things. Civilization is something, as I'll define it, is something that is savable. It is in danger, but it's savable. Is something a lot more than that, and something quite a bit more humane than just these sorts of things. So, what is it? How did it rise? How do we save ours? Well, let me start off by something you may not expect to see. This woman on the left is a woman named Swing Warit, in whose household in Chiang Mai, Thailand, I lived from 1970 for a year in 1976 and 1977. I was a exchange student, and she and her family hosted me to live with them and all those kids in Chiang Mai. It was quite the experience. She had a house full of them. Most of the kids were her grandchildren who she cared for while their parents were working in Bangkok. Bangkok was 10-hour bus drive away to the south, the big city. That's where their jobs were. And I guess they assumed that Chiang Mai was a healthier environment for the kids to grow up in. And for the most consequential year of my life, I was one of those kids. And she was my Thai mother. More on her later, toward the end. The other woman, I'm not sure who that was. I think that's someone who was a neighbor or one of her friends, and they were having a good chuckle while they were preparing food, I think. All right, civilization, if you ask an academic, a historian or an archaeologist or anthropologist or so on, might give you a definition such as this. A civilization is any complex state. So they're defining it in terms of governments and things like that. Complex state characterized by urban development, cities, social stratification, big shots and little shots, writing systems, the perceived separation from the natural environment, that somehow humans are not part of nature. I'm not sure I entirely agree with that as a premise, and when I add social cohesion, there's something that hold these people together into forming a large system that was stronger, at least for a while, than what could have been pulling them apart. Of course, all of them got pulled apart at some point at the end. Other things that are associated with civilizations from the academic point of view, are centralization, a central capital city of some sort, a central king or queen or something, some high, grand imperial poobah of some sort. Specialized labor, okay? If you have enough resources available and enough people, that are talented in a variety of things. Some of them will be much better at making pots. Some of them will be much better at tanning leather. Some of them will be much better at remembering stories and reciting them on cue than others. And some of them will be best at growing food. And so specializing the labor, the specializing the roles individuals took in society was part of what along with, and still is, civilizations. Often culturally ingrained ideologies of progress. That's certainly something that is part of the Western tradition. Monumental architecture, like Angkor Wat, which was a temple and I believe a palace complex. Taxation, because you got to pay for all those temples. And of course, dependence upon agriculture. Not everyone could grow their own food. Often it include very complex and elaborate systems of agriculture, like the Aztecs had in Tenochtitlan, where Mexico City is now on the big lake. It was larger back then. And they had these rafts, these floating rafts, where they would pull mud off the bottom of the lake and put up on the rafts. It contained nutrition, nutrients from decomposing things, and that's how they grew their food, or at least some of it. Now, stepping back a little bit, human beings, we are the children of the Ice Age. We appear in our anatomically modern form about halfway through the last series of ice ages. The last series of ice ages, at least the data we have in high definition, goes back, 500,000 years. And we have some data before that as well, of course. But the data that these graphs show are data from ice cores in Antarctica. And they are of ice that is laid down in yearly layers or in collections of yearly layers. And they are identifiable as to what year they are. And because we have mechanisms for analyzing the ratios of different isotopes of oxygen and carbon, we're able to get a lot of information out of that with the right gizmos and the right people running the gizmos. And so we're also able to pull tiny little dots of air out of the ice at a certain layer corresponding to a certain time and analyze it, so we can see, okay, how much CO2 was or how much oxygen was in the air at that particular time. We can measure directly that way. That requires a special gizmo as well, maybe a couple of them. So we learn a lot, and Homo sapiens in our anatomically modern form, there were our relatives were roaming around the old world much longer than that. But we appear 250,000 years ago. And we appeared right in the middle of these ice ages. Now, this is a illustration showing the extent of the ice at the peak of the last ice age. It wouldn't have been exactly where it was 250,000 years ago, but it was where things were around 20,000 years ago. Okay. And anytime you have a large amount of the Earth's water tied up in ice up on land, sea level's lower. Okay. And you can see that in the shape of the continents. Look how wide Florida appears in this particular illustration. Notice how what's now the United Kingdom and Ireland are part of the European mainland. The sea level was down so that there was no English Channel. Notice how Sri Lanka and India were part of the same continent at that point. Notice how Southeast Asia's shape has changed. How the western half of Indonesia and Malaysia, which are islands currently, were part of the mainland. This is something that was figured out by Alfred Lloyd Wallace back in the mid 1800s, when he was collecting samples for collectors in Europe, and putting together the theory of evolution by natural selection at the same time that Darwin was doing so, using different examples. And they met up later on in London and realized that they had basically done the same, came to their same conclusions at the same time. And they, in a very uncharacteristic example of equanimity, they decided to publish it, their book simultaneously. So no one took precedence over the other. People know Darwin, they don't know Wallace necessarily, unless they are biologists. But you can see that that western part of Indonesia, with Borneo and Sumatra and Java, were part of the Asian mainland. Also notice that New Guinea was connected to Australia, and it's why you have wallabies and tree kangaroos in New Guinea. And most importantly, and something that you have to kind of, imagine this picture wrapped around in a circle, you can see that Asia and North America were connected. At this point, there was a blockage in ice, so that the animals and the humans that were following them could not go by land down into the ice-free part of North America yet. If they had boats, and there's some evidence, I think that they did have boats, some of them did, they could go the sea route. But at that point, there wasn't a big mass migration. Certainly the wildebeest, and not the wildebeest, the woolly mammoths and the woolly rhinoceroses probably weren't into swimming at that point. So, but this is the way the world looked like at that time. Humans show up at 250,000 years ago in East Africa. We can think about and talk about the theoretical mother of us all, who we call mitochondrial Eve, as someone that had direct lineage, genetic link to every human on Earth. There was a person like that. We don't know. Eve is, well, you can imagine why we name her Eve. But anyway, we have a pretty good idea when she likely was on Earth, and that she was likely in the East Africa. And humans started expanding out from there. One group ended up in Australia fairly early on, another group in East Asia, and so on. And it wasn't until much later that the first people were able to get to the New World. There were a number of things that humans always had, even when we were hunters and gatherers and not, in fact, yet farmers. That came later. But during the Ice Age, before agriculture was invented in any kind of scale, we were artists. There are a number of caves around the world where humans would draw pictures of animals. Probably some of them were bragging on their hunting exploits. Sometimes I think people liked drawing, and they would draw different versions of the same animal, maybe to see which one looked good, right? And these were drawn using charcoal and other natural colors in the dark, with very, fairly dim lights and stuff available to them on rough surfaces. So the fact that the art is so good is pretty amazing, and tells you that these people were able to make fine art without going to art school. Other bits of art that humans created were carved into stones. This one in Algeria, this is a antelope of some sort, and it just is a phenomenal drawing. I'm always amazed at it. The posture of the animal and all that is just totally amazing to me. as someone who can't really draw anything to speak of. We also put together some large public buildings and monuments, including Stonehenge, which is a famous one. Another place that I've not visited yet, but I'm looking forward to it someday. And of course, the volcanic rock heads on Rapa Nui. One could do a whole lecture, and maybe I will as in the future, a whole lecture on the amazing things about Polynesian culture. And one of those is that they were able to sail from west to east when the wind and currents were going most of the time from east to west. Another thing is how much guts does it take to sail in a little boat over the horizon when you don't even know that there's anything over there. Well, anyway, one of the things that the farthest east they went, as far as we know, is in this island, which was by Europeans called Easter Island. I think Cook named it that. And but to the Polynesians, it was Rapa Nui, and they made these iconic faces, which are amazing pieces of art as well. What most people don't realize is most of them had little red hats on their head too at some point. There's a few of those left. All right. Now, there's some apparent important milestones. The sense of time is a really hard thing for humans that have our own, 80 or 90 years of lifespan to wrap our brain around it. And so I always like to give a little bit of scale and take a look at all the zeros. Earth was formed at 4.7 billion years ago. The earliest possible life, we don't know if the life was existent on Earth at that time, but the conditions would have allowed it, and life would have been bacteria at that point. 4.28 billion years ago. Animals didn't show up till 540 million years ago. The first humans show up 2 million years ago. Anatomically modern humans, as I mentioned, is 250,000 years ago. The end of the most recent ice age, 16,000 years ago. Where we are in Connecticut at that point was under about a mile thick layer of ice. Agriculture wasn't invented as far as we know until about 10,000 years ago. And the Industrial Revolution was only 220. And then the Beatles broke up 50 some years ago. 53 now, 53 years ago. I show that Beatles thing to my students and they all look at me like, oh, I know who the Beatles are, but what, they think I'm a nerd. All right, now, in order to have agriculture, we had to be able to manipulate the genetics without really knowing what genetics was, plants and animals to get a increased production of these potential food sources. And the first plant which was domesticated was actually a gourd. It was the calabash, which was not used for food. It was used as a container. You can imagine if you went along a long hike that would last weeks, what would you carry water in? Well, there weren't many options other than the bladders of animals. All right. So one of the things, the next plant that was probably, as far as we know, was domesticated was wheat, and it required a particular mutation to occur so that the wheat kernels would stay on the stalk after they were ripe. In the plant's general way of reproducing, the plant would drop those seeds just as soon as they're ripe so they could grow into more plants. Okay, but there was a mutation that kept some of them on the stalk, which meant that humans could come and pick them off. If you picked seeds off the ground, there's a high likelihood they'd be spoiled, and that wouldn't be good for food. And so some brilliant human came up with those seeds and then planted a bunch of them and realized that the wheat that grew after that had a higher proportion of seeds that stuck to the stalk, and on and on. Okay, it was a matter of selective breeding that somebody had a sense for it, had a eureka moment, and invented and invented the domestication of wheat. And then other plants were then added to that as well. First animal, which was domesticated, was the wolf, who basically domesticated himself. Some groups of wolves would follow after humans and realize that their best opportunity for a meal was eating our trash, all the bones and guts and stuff from the animals that humans were eating. And so they modified their own behavior to allow us to keep them around. And gradually, over time, humans started taking over the reproduction of the wolves and deciding which wolf was mating with which wolf, and so that we could select for traits. And eventually you get to, well, my little dog, Ringo, a terrier, who's exiled into the kitchen right at the moment because he would be a barbarian otherwise. Okay, and all the ridiculous kinds of dogs that we all love so much, all are the same genetic species as wolves, and they could interbreed if they were physically at the same size to do so, like German Shepherds are. Now, there were a number of places around the world where plants and sometimes animals were domesticated. Not all animal or plant is suitable for domestication. There has to be certain characteristics they have. For one thing, zebras were never domesticated, even though their close relative horses were. And the reason zebras were never domesticated, even though people tried a bunch of times, was the zebras had this tendency to bite and then not let loose, which kind of made them less popular among farmers and animal breeders. You could tame them, but you couldn't manipulate their reproduction, which is how we define domestication. Some of the hotbeds of sources of plants that were, spread around the world subsequently, of course, was the Fertile Crescent in the Middle East, where we got most of the farm animals that we're familiar with: horses and pigs and cows and sheep and goats and all that. There were other cow-like things in India that were their breeds of cattle were probably domesticated separately than the ones in the Middle East. And the New World, we had the whole camel complex of vicuñas, llamas, and alpacas in the Andes. And of course, the Incas fed their civilization on potatoes, which would grow nicely up in the mountaintops, which also allowed them to grow under moist conditions in Europe. And the people in Mesoamerica domesticated turkeys and corn and peppers and squash and the Three Sisters and all that, and rice in Asia, and some forms of yams and yams in New Guinea. And all these plants domesticated, bananas, sugarcane, all that stuff, and were then spread around the world where they would grow, where humans realize, hey, those bananas taste kind of good if we can get rid of the seeds. I had the crazy experience of biting into a wild type banana once in Thailand, and I thought I was going to lose a tooth. That's a different story. Another thing that humans do, besides being farmers and artists, is that we are scholars. And ever since the systems of writing were made, and systems of mathematics were made, and the ability to conceptualize a zero, that was a particularly important one. The Maya did it in Central America, as did people in Asia. And when we found ways of writing down and sharing our ideas and having other people argue with us on what's right and what's wrong and all that sort of stuff, we became scholars, and we could think in the abstract, and we could work toward the future and do a lot of things that were amazing. These manuscripts, by the way, came from that great library in Timbuktu, which is in the nation of Mali now. Another institution of great learning is right here in our hometown, Western Connecticut State University. I've been a professor there for 26 years now. This is our science building. if anyone would like a tour, or better yet, bring your college-age students and your kids and grandkids, and I'd be glad to take them on a tour. All right, so we got to Ice Age is over, agriculture is over. I mean, is started. One of the great revolutions, and by revolution, I don't mean French Revolution or American Revolution and all that. One of the revolutions was the Neolithic Revolution, where we started to use metal and we started to domesticate crops. Okay. But another big one, which is we're dealing with it, the results of it now, both the good and the bad, was the Industrial Revolution. And that was just a couple hundred years ago. And it was a good news, bad news situation on one hand, and on the other hand, it was seen as unmitigated progress at the time. What was special about it, and what fueled it, was some inventions. One invention was the steam engine. There were steam engine-like things that had been used for quite some time. Used burning wood to heat water, which would build up pressure and make things move and turn and go around in circles and so on. As we developed more efficient steam engines, and most importantly, realized that those black rocks that people were digging out of the ground in some places actually burned quite well. Okay. Then we started to be able to connect these steam engines with big looms for weaving cloth, and to locomotives, which would allow us to go long distances on rails, and any number of other things, including one that's going to surprise you later on. You may know about it. Well, so before the Industrial Revolution, the economy was based on manual labor and draft animals. You got to think of it. At any point in human civilization, there were draft animals, or there had to be some sorts of energy. Okay, before we had draft animals, of course, it was mostly human. You know, we were the draft animals, and so we were the ones that would carry stuff if we were, out on a hunt or whatever, or moving from one location to the other. Humans had to do all that work. We had nobody else to do it for us. And gradually, as we domesticated animals and bred them to be good at carrying things and pulling wagons later on and so on, they were the source of energy. We also, some cultures developed windmills. There is a windmill structure in Iran to this day, which is used. It's a couple thousand years old. That's used for pumping water, I believe. I'm not sure exactly. So some of these things are very effective and very useful even to these days. And the Dutch, of course, have used windmills to keep their field dry. I remember as a kid driving around Missouri, where I grew up, and seeing farmers who had big windmills that they would use to pull water out of the ground to fill the stock tank so that the cows could drink. It was also during my lifetime that they had switched from windmills to diesel motors for reasons which I'm sure a good salesman talked them into it. But it's a shame that they had this great technology and they decided to do something else. But anyway, that's another story. So before the Industrial Revolution, the energy was somewhat for humans, and a lot of it was draft animals. And the technology associated with hooking a horse up to a plow to pull a wagon or so on changed over time as we better understood the nutrition of what the horses needed, and built harnesses which were more comfortable and would encourage them to work harder for us, things like that. We did our manufacturing by hand and simple machines. Productivity of goods were low as comparison to later on. And we basically built fires from wood, biomass, peat, animal feces, and we used river flow as an energy source. In the current understanding of it, that part of human civilization was carbon neutral, by which we mean that the total amount of carbon in the atmosphere was not increasing as it has been since the Industrial Revolution. Now, one of the things that drove the Industrial Revolution was the fact that people like cotton clothes. Probably most of us are wearing a shirt that is, or maybe a pair of pants that are mostly made from cotton, as opposed to flax, linen, and wool. Okay, people used to wear wool underwear, but I can't imagine them being all that comfortable. But cotton is comfortable and it's cool in hot weather. And as cotton began to be grown, it was grown, there was a great demand for it. The demand exceeded the supply because it was just more comfortable. And it was discovered that cotton grew quite well in some parts of North America, as it did in Egypt and some other places. And plantations of cotton were planted. In fact, one of the reasons for the clearing of Native Americans in southeast part of the United States by Andrew Jackson was to free up land so that cotton could be grown in larger quantities. Now, this wouldn't have been that useful and probably wouldn't have bothered to do it, at least not in that way, were it not for the fact that separating the fiber from the seeds was a labor-intensive process. Okay, before 1800, it was done by hand using something called cards, which you can still buy, by the way. I found these pictures up on eBay. You could buy cards if you want to try it. But it required people to, using these two paddles, move back and forth in such a way that the fibers are separated from the seeds. Now, the seeds had to use too, oil and things like that. And in order for this to be done in great quantities, it had to be done by slave labor. And so prior to 1800, that was the only way to get cotton, was to card it. Until this fellow named Eli Whitney, a Northerner, invented a machine to do it quickly and efficiently. His hand-cranked cotton gin made the process so much easier, more comfortable, and required less labor to separate the fiber from the seeds. This is a picture, a reproduction of his what am I trying to say? Well, it was one of his first models of the cotton gin when he was anyway. So in the early part of the 18th century, later part of the 18th century and early 19th century, cotton production increased greatly. That changed North America immensely. Slavery was on the way out probably, and now it became a source of great wealth to the detriment of us all, and to the detriment of the Native Americans who were dispossessed of the land so that these cotton plantations could be built. Before the Industrial Revolution, the cotton thread was spun into cloth using a hand loom. Okay, an example here, made of wood largely, with some parts in metal. Had to be operated by a single person who would be in effect doing it all. Okay, and there are still people who do this as a craft. The Industrial Revolution allowed humans to hook up big steam engines to do it in industrial scale, and of course made it necessary to have metal machine tools and metal machines so that these things could be done with less maintenance required. In the early part of the 1800s, the industrial production of textiles was largely in the British Midlands, which was not so far away from the coal mines of Wales. And the engines powered by steam engines, boilers fired by wood and later coal, and centered in Britain. They couldn't grow cotton in Britain, so the demand went out for more cotton to be grown, and there we have a great part of our history. Now, those British people who made their living as hand loomers were not particularly happy with the industrialization. They lost their way of life. They lost their livelihood. They staged a revolt in 1811 to 1812, and they used as the fictional leader of their revolt, King Lud, L-U-D-D, Lud. And they, for a few months, burned new mills and weaving machines, and they became known as the Luddites. Now, some of us of a certain age probably remember that people who are having trouble or showed no interest in learning how to use, computers were called Luddites, and that's where the term came from, by those followers of the mythical King Lud who did not want to lose their ability to make a living as hand weavers. And here is Lud himself in an illustration of the time. He was supposed to be a big burly guy wearing a gingham dress. All right, and the burning of coal to fire water and steam engines, and the manufacture of first cloth, and then all sorts of stuff, including steel. Coal made the production of steel much easier, and so on was shown at the time, probably encouraged by the people who made the most money on it, to be, a great and wonderful thing. And so if we look at the years 1800 to years 1900, what a big change there was in terms of, and this is scaled to the energy requirements, labor costs, energy requirements per hour, per hectare of producing American wheat, just as an example. The winnowing, in 1800, there was no winnowing after that because it was machine. Hours of labor to produce to grow and harvest wheat from a hectare was 162 at the beginning of the century and 9 at the end. The amount of energy in terms of raw physical energy required to do it went down as well. The net food energy return was 90 to 240, okay, to 2400. The labor productivity then went from 7.2 kilograms of grain to labor, the amount of labor that went into it, 0.4 minutes per kilogram of grain. And so a vast change, and that was due to improvement of machine tools and the McCormick Reaper, no doubt, and steam engines and fossil fuels and the whole bit. And in fact, not so much for the American wheat, but for industrializations in general, chattel slavery. Now, the benefits of the Industrial Revolution were more and cheaper goods. textiles in particular, and later other things. Steam power for other uses, railroads, for instance. Iron smelting, refinement of chemicals. And one that you may or may not have ever heard of, a gentleman in England named Charles Babbage invented a steam-driven mechanical computer, his difference engine. And it was a decimal computer, not a digital one. Okay. And the woman who programmed it, invented the programming language, was Ada Lovelace, who was Byron, the poet Byron's daughter. Byron was married to an accomplished mathematician, and their daughter, Ada Lovelace, was the one who programmed this thing. And there's only a couple of them still in existence, both recreations. Steam computer. Maybe that's why, maybe that inspired steampunk. Anyway, the costs, of course, and there were costs, were industrial cities, tenements, and pollution, child labor, because all those machines for weaving required, small, nimble hands to keep everything working right. And often those nimble hands got caught up in the machinery and harmed. And that was one of the reasons why child labor laws came into being, is to give kids some relief. And as the topic of this series, its cost is the transfer of carbon from underground into the atmosphere. By burning fossil fuels, what we're doing in essence, and not in essence, in reality, is to increase the amount of carbon in the biosphere, in the carbon cycle. Carbon that was underground for 300 million years previous. All right, so here are poor lads working the mills and having to do a lot of dangerous work. Now, all that fossil fuel stuff that has been burnt, of course, releases methane and CO2 into the atmosphere, and has had a whole variety of different effects on the natural world. Okay. Including the obvious ones of air temperature near the surface increasing. Okay, carbon dioxide and methane and some other gases as well, including water vapor. Only water vapor is very weak at it. Absorb infrared, and so they are in fact the glass in the greenhouse that we all live in. We're all in the same greenhouses, as a famous astronomer once said, Carl Sagan. But it also affects all sorts of other things, including ice melt and sea level rise and ocean heat content and carbon dioxide dissolved in the water, acidifying the oceans and making it harder for those organisms that need it to get calcium. And it's changing the seasons and all sorts of things. Think about it. Here we are in New England, and we're about to have our first significant snowstorm right at the end of February. And temperature has been going up. And these are not due to the natural processes. Some people ask, and it's a reasonable question, how do we know that it's not the natural processes which change the temperature from ice ages and out of ice ages? How do we know it's not that's happening and something the human's doing? Well, there's a whole bunch of evidence that nails that. But one thing to consider is all the processes by which ice ages came and went under natural conditions took thousands and tens of thousands of years to happen. The Industrial Revolution happened 220 years ago, and we have gained more heat much faster than in natural conditions could possibly manage. That's one of a number of lines of evidence. And small changes in averages lead to big changes in extremes. Scientists are trying to, and some public officials and kids are trying to tell us that we need to limit the amount of temperature increase since the Industrial Revolution to 2 degrees Celsius, or we'll be in bad shape. And we're going to have some problems anyway. Ideally, we'd be able to pull the CO2 out and go back to the way things were in 1800, but that's not going to happen in the near term. We would like to keep it at 1.5 if possible, because at that temperature, global average, the major ice sheets in Greenland and Antarctica will stay intact, and that will save us a great deal of suffering. If the temperature goes to 2, that would mean that they will likely collapse, some quicker, some much slower. 1.5, 70% of the coral reefs will be lost. At 2, almost all of them will. And up till now, since 1900, there has been an increase in temperature of 1.2 degrees Celsius. Now, one of the effects that's going to have is that whenever you warm water, and this is something you can prove to yourself in your kitchen, when you warm water, it takes up more space. Okay, so all that heat, 93% of the heat captured by fossil fuels is going into the ocean. It's going to warm that water and make it take up more space. And people living on very near to sea level, like these folks in Bangladesh, are going to be in peril, and not just there. Shanghai, China, is the city that's in the most danger because it's right out sea level and there's zillions of people there. And lots of sea level vulnerability on the Atlantic coast as well. And it's already happening, but our future is hundreds of millions of climate refugees. People not only getting up and leaving because sea level rise, that's part of it, but also because of drying in some areas where they'll no longer be able to raise crops and make a living. That happened, imagine what happened in the 30s in the Dust Bowl, and basically imagine a Dust Bowl that takes up half a continent. There is hope. Our hope mostly is not all of us old folks, but these people, the young among us, who seem to have a better grasp on the reality than their grandparents do. And there are increasing number of young people are coming to college with a great deal of anxiety about the future and the environment and so on. I talk to these people. I know them. I can list a bunch of them. I won't, because it's not public information, but it is the world that they have inherited, and they are going to have to be inspired and helped to do something about it. And that's what I do. We are not helpless. I once asked Jane Goodall, the Jane Goodall, the environmentalist and animal behaviorist, who has a long-standing connection with Western, my university, and I've met her 4 or 5 times on campus. She came to WestCon. She's a famous person. She came to WestCon, and Pete Seeger, who was the folk singer, was still alive. He was over on the Hudson someplace, and he came over and met her and shook her hand, and she had no idea who he was. But she was very good sport about the whole thing. I asked her, what is the most important thing that humans can do to reduce their fossil fuel emissions? And this is what she said, and I quote, "Think about what you do each day, what you buy, and what you eat. Be conscious of the world. Be conscious of what our civilization is running on, what we're doing, the effect it's having on people and ourselves." Now, let's get back to my Thai mother. This photo reminds me that our civilization, now so much in danger, is not made up just of majestic buildings and great pieces of music and ancient ruins and cultures per se. Most importantly, our great civilization is made up of ordinary people. They're the people who hold it together if it is to be held. Magnificent people like the woman who raised a bunch of kids, made sure they did their chores and homework and taught them manners. Human civilization, that which we are here to save, is humans. Ordinary humans, not famous ones, not famous football players or famous politicians or anything like that, but the rest of us, you know. In a global community, the golden rule must apply to people who we have never met, living in countries we've never visited, because there was a time when what one person did not really affect anybody out of a very small area. That is no longer the case. What I do now is affecting, in some degree, people everywhere on Earth. And we have to remember that particular bit of spatial scale. And that's what I have to say. I would be happy to answer questions. If I don't know the answer, I'll tell you I don't know the answer.
And thank you so much. If you have any questions, please type them in the chat.
Well, let's see, where's the... All right, here's the chat.
Any questions?
Not everyone at once. I can say that climate change is an issue of humanity. It's an issue of ethics and morals to me. It is part of what we must do to make the world good for our children. Native Americans, some of the groups came up with an idea that we should use what's best for 7 generations in the future when we're making decisions. I think that's an excellent idea. Think how many problems would be avoided if we did that. I
agree. And I also am happy to see that my own children are taking that into consideration very seriously, very, very seriously. And we have a question from Anita. I'll read it off to you. Of all the places that you have lived, which is the one that has the best chance of succeeding given the climate change challenges?
So, and we define success as survival, or in not losing much of their modern conveniences.
She has replied with survival.
Probably the people who live off in the villages somewhere. And I think I lived in Thailand, I lived in Belize, and there are a lot of people who know how to live simply, and maybe they don't live to the technological level that we're used to with computers and whatnot, but they live and they are able to keep their cohesiveness in those Starbucks. Yeah, that's right. And so I've met people, rice growers in northern Thailand, and people out in villages. People in villages are often what seem to me psychologically healthier than those of us who live the high life. I suspect that they'll be around. If we go down, they'll be the last to go down, because they know how to survive. And also natives in Alaska. I lived in Alaska for years, and I went to grad school up there, and lots of natives and some other not natives know how to survive, and they will.
Any other questions for Dr. Mitch Wagener for this evening? If not, I think everyone is concerned
Well,
about the snowstorm, impending snowstorm.
yeah. Feel free to share my university email if anyone has a question or if they want any more information on the Jane Goodall talks.
And as soon as I get that information, if you want to send it to me, I will be sure to forward that information to all of you as soon as I get that from.
We have a flyer made up, and I can just send you the flyer.
Okay, yeah, that's fine.
PDF, so you can send it on.
So, okay, everyone, thanks a lot for joining us. Be sure to register for our next and final presentation in the series for March 27th. Where do we go from here and what future would you like? And at that point, we will have an open discussion where we will be all talking and everything. So I think that will be a very interesting coda to this series too. And, if you have any questions, please feel free to email me before then. But until then, I thank you, Dr. Mitch, again for another wonderful presentation. And to all of you joining us this evening, be safe. Take it easy tomorrow if you have to go out, and be sure to shovel the snow. Use your knees, not your back, and take it slow and take lots of breaks. All right, everyone. Have a great evening.
Bye.